Chapter 1, An Introduction to Networking, Part 1. Wait, what? Part 1? Does this mean that these lectures are so long that we have to have multiple parts of them? No, it doesn't. What we're doing, though, is trying to keep these individual lecture videos fairly short, right? I want them to be easily digestible, little bite-sized chunks. I keep talking like that. It sounds like I didn't have breakfast today. Point is, we want to keep each individual session as short as possible just to make it easier to watch and make it easier to absorb. It's going to be okay, I promise. What we're looking at today is really defining terms, right? There's terms we're going to use throughout the semester. And we're going to be talking about defining what even a network is, and then going into some specific details beyond that. Well, let me tell you what, back in the old days, and I mean way back to the IBM PC in the early 80s, these computers weren't networked together. They sat on people's desks. You'd walk into an office, you'd have a big, fat PC sitting there, and they were big. They were very big, very heavy. And you would store your data on things like floppy disk. Well, how do you get information from one computer to the second computer? Maybe your partner's office down the hall. Well, you did it by something called SneakerNet. You'd put the data onto the disk, you'd save it, remove the disk, and then walk down the hallway, plug the disk into the other person's computer, and copy the data off. It totally worked. It really did. But obviously it had some scalability issues, right? That type of environment can't really support a large enterprise. Something better had to come. By the late 80s, we started seeing these peer-to-peer models, right? And they looked like this. This was the first networking, where each computer would have a network card in the back of it. We'll talk more about those later on. And then they would be plugged into a network where they could talk to all the other computers. But look at what peer means. A peer means an equal. So all the computers on the network were equals. So I might have some information over here. This might be Bob's machine. This Word document might be on Susie's machine. This Mac might hold the scanner. And I could send information over the wire, but no one computer was more important than the others. No one computer controlled any particular process. Data was very distributed throughout the network, right? And that had some problems also, similar to our SneakerNet limitations, scalability. This can only get so large before it becomes untenable. In some larger families, we see this on our home networks, right? Because everyone has documents spread all over their individual computers. How do you back them up? How do you know where it is? You could end up with multiple copies of the same thing. It becomes very, very, very hard to manage. Also, every computer makes use of what's called its own local security accounts manager, its own SAM accounts, which means it only respects users on itself. So if we're trying to employ any kind of security at all, it becomes very difficult. There were advantages to this. Obviously, it's simple. I mean, you don't get a much simpler network than this. And as far as expense goes, at least an initial outlay expense, yeah, you're not paying for server class software or hardware. But you'll find that cost may come up later on in terms of business productivity. Its disadvantages, like we talked about, it's not scalable. And when I say scalable, I mean ability to grow. And if we don't design our networks to be able to grow, then we end up throwing them out every time our business expands or something changes, and that doesn't make good financial sense. So we need our environments to be agile and flexible and able to grow. Remember the local security account managers we talked about? What that means is that security is very hard to enforce. Really what people end up doing is shutting off security for convenience sake. Well, that definitely isn't secure, and in most instances can cause us some real problems. By the 90s, we started, as IT environments started to grow, we saw the spread of client-server architectures and applications. What this means is you have a server. Now, a server can be both a piece of equipment, i.e. server class hardware, or a piece of software providing a service, right? It's an application. And we know these services. How about a web service? Web servers. We go to those every single time we browse the interweb. Email servers. Where does our email come from? Well, we have clients that are attaching to email services. And there's others that are more IT specific. FTP, the now way obsolete Telnet, remote desktop, that type of thing. So what does client server look like? It looks like this, right? Now this is a one server to many client relationship. And look at this example, a web server, right? And it is. This one web server may get thousands of hits every hour or thousands of hits every minute from different clients all over the world. One to many. The client makes a request to the server then pulls up whatever information was asked from it, like a specific web page. Maybe you want to know what today's weather is, what the stocks are doing, were doing yesterday, somebody's latest golf scores, whatever. The server pulls that up and then returns it to the client. Servers, while they do talk to clients, and that's quite frequently what they do, they can also talk to other servers, right? A server can also be a client to another server. Prime example, email. Email servers are really analogous to post offices. You know, you go to Portland, Maine, there's a post office there. You go to Biddeford, Maine, there's a post office. Well, if you're in Portland and you want to send a letter to Biddeford, what do? You address it, you throw it in a mailbox. It gets sent to the Portland post office. The Portland post office sorts it and sends it to the Biddeford post office, where it gets sorted again and then finally delivered to the destination mailbox. That's exactly what's happening with email, right? If this person up here is in organization A, Acme, and this person here is in organization B, Widgets Incorporated, and he wants to send an email to her, his email client, sends that email to his email server, analogous to his own post office. His email server sends that to Widgets Incorporated email server, which in turn delivers it to the recipient's mailbox. So servers can talk to clients. That's frequently what they do. However, they can also talk to other servers. This client-server thing has really taken off as far as many aspects of IT, most aspects of IT, really. The client-server network model. When you see this acronym right here, AD, that stands for Microsoft Active Directory, right? And that is the Microsoft username and password database, if you will, of all the users in an organization. So now, remember back to our peer-to-peer, local security accounts on every single client. Active Directory, a client-server network model for authentication, means that there's one server on the network that holds all the security accounts, and all the clients must request username and passwords from that server. Somebody goes to sit down at their workstation, they log in with their username and password. My username is Bob, my password is password1. That client then takes those credentials, and that's what a username and password are known as, credentials, and it sends it to the Active Directory. And in this case, it's called a domain controller. The domain controller verifies the credentials. Yes, I have a user named Bob. Yes, his password is password1. Please let him in, and here is what that user is allowed to do. So now Bob can log in from any client on the network, whether there be 5 of them, 50 of them, or 500 of them. It doesn't matter. Everything now is centralized, and that is the whole point of client server. It looks something like this. Look at this. Here's our domain controller. It's a Windows server. Domain controllers and Active Directory are synonymous. A DC is a Windows server that is hosting Active Directory by definition. And here's all these clients connecting to it. Sometimes the clients aren't even compute nodes, if you will, or in the traditional sense, a printer can authenticate to a domain controller. Right? Scanners, all kinds, any resource on that network can report to the DC. These client-server models allow us to scale largely, right? This makes sense in even small environments. You could set this up in a small 2-person law office with an Active Directory domain controller and 3 PCs, and it makes perfect sense. Or you could set this up in a Fortune 500 or Fortune 100 company, a mega enterprise with thousands of clients. It still works, and it still works conceptually the same way. Now, for client-server networks, we make use of something called a NOS, which is a network operating system. This term used to have a lot more significance than it does now. Quite frankly, because all operating systems nowadays are pretty much network operating systems. This didn't used to be the case. If you recall back to the Intro to IT class on our history of operating systems, old OSs like DOS weren't designed to work on a network, right? Windows 3.1 and all this other stuff. They were not network operating systems. Windows NT, however, was. Well, what are we working nowadays? If you're in the Windows world, we're working with the descendants of Windows NT, right? So they're all network operating systems. Network operating systems tend to have 2 pieces. They have a server component and a client component. Well, in the Windows world, that comes down to 2 different versions, right? I can have Windows Server, the current release, Windows Server 2012 R2, on my servers in my data center, and on my desktops, I'm going to have Windows Server, I'm going to have Windows 7, 8, or 10, right? The client version of the operating system. They interact with each other. Really, under the hood, they're in many cases they're the same kernel. They have different purposes. If you start getting into the Linux side of the house, and many times this is the exact same operating system. I can have Red Hat Enterprise 7 on my client, and I can have Red Hat Enterprise 7 on my server. Same operating system, it's just how they're configured. One's configured to be a server, one's configured to be a client. We already talked about this. These type of operating systems, they ensure authorized user access. That's not only username and password, but making sure that security is enforced. And that means that I may not want anyone else looking at my files. So I set permissions in my files so that only myself or select individuals can look at it. Well, what controls that? What enforces it? The operating system, right? User file access, controlling access on the network, and access to resources on the network. File servers, printers, scanners, whatever. Application delivery. Ultimately, this is what IT is all about, right? Delivering applications to enable business processes to operate. No one, and I mean no one in an organization outside of IT cares about our fancy server room, our tricked out servers, this great virtual environment. They don't care. What they do care about is when they click on an icon, something opens and they're able to do their job. That's what application delivery means. And that's ultimately the purpose of all of this. We're going to introduce a new term right now. We're going to look at and we'll see it again and again, and it's called topology. Well, what does topology mean? Really, it kind of means a map. Right? Topological map. and it describes what a network looks like. We use two different types of topologies. Topology can be physical, right? And by physical, it means what's actually in the room. It describes what computer is sitting on what desk, where the wire goes, where it goes into the wall, how it goes up to a cable tray, where it distributes to the building, where the server room is, all that. It's actually a map that you would use to figure out where your equipment is, right? It is physically what's there. We also talk in terms of logical topology. This is a map also, but not necessarily of how things are physically, but how they operate. This is a logical topology. Assuming this is a domain controller, we're showing all these different clients reporting to this domain controller. But physically, that's not what this looks like. I mean, it doesn't have 5 NICs in it, and every machine is just plugged into it. No, this machine is actually in an equipment rack somewhere, probably virtualized. These clients are probably plugged into access switches, which in turn are plugged into core switches in the data center, and which the DC plugs into. This just shows logically how it works, how the software works, how information flows. So which one's more important? Well, the answer is yes. You need both. As an IT person, as a network administrator, you need to know physically what your environment looks like, and you also need to know logically how it functions. This is a better example of a physical topology, right? This could be something right on somebody's house. A centralized switch, wired computers actually plugged into the switch. This topology can go so in depth that you can actually label what switch ports are being used by what device. And it's very common in physical topologies to go to that level of detail. It makes a lot of sense. You want to know what you have. 2 o'clock in the morning, things are breaking, phones are ringing, people are crying. You don't want to have to go and figure out, where is this server plugged into again? You want to know exactly where it's plugged into and into what port. So physical topologies can be extremely detailed. We talk about networks. I keep throwing that term around, network. Network is a bunch of computers connected together. But we can go beyond that. Usually what we're talking about, when we talk about network, and especially within this class, we're talking about a local area network, right? Also known as a LAN. That means the network to one building, one area, one home. My house has a local area network with a cable modem, a 4-port switch, 2 wireless access points, about 5 different tablets, and maybe 4 different laptops, right? And a bunch of iPhones. It extends within the borders of my house, and that's it. That is my local area network. For a company, for a small company, it could be the network that just lives just inside their office, right? Or maybe the network that lives just inside their building. There's terms for networks that grow even bigger than that. We'll look at those in a second. But for our context, when we say network, this is what we're pretty much defaulting to, a LAN. There's a device that we're going to see a lot of called a switch. It's this guy right here. There's a lot going on with a switch, but for right now, we can just think of it as a device that we plug computers and network devices into, right? We'll talk more later on, but for now, that works. Okay, topology. Topologies can take all kinds of shapes and forms. We're going to look at those in upcoming weeks. A most common one that we see is a star topology. Right? It's not the only topology out there, but it's one of the most common. This is a star topology. There's the center, and here's all the rays of the star coming out. What connects these devices to that network, to that LAN? Well, it does it by use of a network interface card, or a NIC. Now, NICs can take many forms. They can be physical cables that you plug in. They can be copper. They can be fiber. They can be wireless. There's such thing as a wireless NIC, which uses radio waves. But by definition, a NIC is a device that allows a device, a computer, a printer, a tablet, whatever, to connect to the network. Here's some of the stuff in action right here, right? Star topologies, 3 of them. The switches are actually connected in something known as a bus topology. More on that later. And every one of these devices has a network interface card of some type connecting it to those switches. Other terms we'll see, we'll throw this around, a router, right? A lot going on here too, but right now think of a router as a device that connects networks together. Switches connect devices together. Routers connect networks together. Like so. This would represent 3 separate networks. They only come together in one point, and that's at the router. Now, I said that things can grow beyond a local area network, and they totally can. What if we get bigger? Well, look at our college, right? The SMCC network spreads over the entire South Portland campus. Well, that's even bigger than a LAN. Technically, that is called a campus area network, or CAN. Yep, it's a real word. We also have satellite campuses, right? Those are also connected to the network. Well, those are going across the city or going partway up the state. If I have a network that spans a city, and that's not uncommon, by the way, especially for governments, city governments and all that, that might be known as a metropolitan area network, or a MAN. Principles are very similar to the local area network, it's just way bigger. What if we go bigger than that? What about going from one end of the country to the other, or one end of the globe to the other? That becomes what we call a wide area network, right, or a WAN. Ultimately, the internet is the biggest WAN of them all, right? And it is. These all refer to the same thing, connecting networks together. It's just in terms of scale. We don't mention it here, but guess what one of the smallest area networks is? How about a personal area network, a PAN? Totally exists. Don't believe me? Do you have a smartphone? An iPhone or an Android or something like that? You make use of a Bluetooth headset? Maybe for wireless earbuds, or when you get in your car, does your phone connect to your car stereo system so you can play music over the car stereo? Well, that's a Bluetooth connection. Bluetooth enables personal area networks. The network extends as far as you do, right? I walk around carrying my iPhone. I have a network that extends about 2 feet all the way around me. And wherever I walk, that network goes. Wherever I carry my phone, anyway. Really, it's all the same idea. It's a matter of scale. Other terms we're going to see come up, and don't stress on these. We're going to spend way more time defining what these terms are in detail and really taking a closer look at them. But ultimately, what are networks doing? They're enabling communication, right? That's the whole reason people first started connecting computers together, so they could communicate and exchange data. Well, we communicate in a variety of ways, right? We talk on the telephone. Well, at least we used to. You go into an office, there's still a thing on the desk with a cord coming out of it that you'd pick up and talk into. That's one method of communication. I might send somebody an email, right? Using those email servers. That's another method of communication. Maybe we'll do a Skype. Maybe we'll do a face-to-face, like a FaceTime kind of thing, right? Teleconferencing. That's yet another type of communication. Long story short, in past years, these different types of communication mediums were separate. And you had to have separate networks for all 3 of them. Well, nowadays, we make use of this thing called convergence, where we have one network that enables multiple types of communication. And when we have that, it's referred to as unified communication or convergence. Right? And we totally do. I mean, I'm sure somebody out there uses their iPhone to send email, to maybe text message, to communicate on Facebook, to FaceTime with each other. Well, you're using the same network and the same network technologies, but you're doing 3 different types of communication. And that's what that means. Convergence is using the same network for multiple types of communication. That was quite a chunk, wasn't it? Go ahead and stop here. Let's go ahead and digest some of this. And when we come back for part 2, we're going to examine one of the most critical concepts you're going to learn throughout this course, and that is the OSI and TCP/IP network models.